So today the question is, what is fraction equivalence? You have probably heard of fraction equivalence before. Equivalence means two things that are equal or equal in value to one another. You may have been taught something that looks like this. If I want to find an equivalent fraction for 1/2, I can multiply the top and bottom by the same thing, and I'll get an equivalent fraction. So of course this does work, but it doesn't really have a lot of meaning behind it. Why did these arrows suddenly appear? What did they mean? They don't show up elsewhere in math. What does that have to do with anything? I call these magical rainbows because they seem to have no meaning and they kind of look like rainbows. So let's talk about the meaning behind that procedure, because if we understand the meaning and if we teach our students with meaning, then they're more likely to understand and be able to replicate in the future. So first things first, if we think about a square where we have, let's say, 1/2 shaded in. There's my 1/2. I could cut that square just one more time. And now it's cut into 4 pieces. And that amount that's shaded, that same amount that's shaded, is now 2/4 of my square. You've probably done this with students before. If you've taught fraction equivalence, you've probably seen it. So let's talk a little more about those magical arrows. So there's a really cool property. Maybe like me, you were made to memorize all the properties and their names and what they were, in particular the generalizable descriptions of them when you were in 8th grade. It seemed like a giant waste of my time, and I didn't understand why I was doing it. In fact, it wasn't until I was in my doctoral program that I really got why many of those actually mattered. Those properties are really the hallmark of our number system. So the multiplicative identity property is one that seems like a duh to most 3rd graders. And that's the idea that any number times 1 is itself. The generalizable way of saying this is a times 1 is a. And so kids will agree with you that 3 times 1 is 3, 99 times 1 is 99. And by the same notion, 1/2 times 1 is 1/2. They also, by the time you're talking about fraction equivalence, know about fractions that equal 1. These include any fraction where you have the same integer over itself. Of note, you could have a over b over a over b, and that would also equal 1. But let's focus on this a over a. Any number over itself equals 1. So some examples that are 2/2, 3/3, 4/4. Those are all equivalent to 1. So if we put these two ideas together, I'm going to move this equation down here. I know that 1/2 times 1 equals 1/2. But actually, this time, instead of multiplying by 1, the normal 1 that we use, I'm going to multiply it by a fraction that equals 1, or 2/2. When I multiply fractions, of course, we multiply them straight across, numerator times numerator, and denominator times denominator. And so 1/2 times 2/2 is 2/4. This is how the multiplicative identity property can help us explain fraction equivalence. So I'm going to try to encourage you not to use magical rainbows in the future.